The start of section 8.3 day 2 begins with a review of doing an evaluation of a logarithm. So in the very first one, this is a very straightforward question. It says evaluate this. I always say imagine you could type this into some calculator, log 264, and many calculators can easily do that. Most simple calculators are designed with a base of 10, but with technology advancing, it's not hard to have a calculator to type this in. What we're trying to say is, what would it equal if you just typed it in and hit equals? So this would be a way you can do it by hand. We just let it equal x, and then we do the little loop around. We take a logarithmic expression, now it's an equation, and we rewrite it exponentially where you go 2 to the power x equals 64. And then what simply happens is you're just trying to say, well, what would be the value of x? You could either just eyeball it and say it's a 6, or you could get the same base that's in the PDF version of the notes. For the second example, now we start to see some of the restrictions. Early on in logarithms, I think it might have even been the first day of chapter 8, we had written down certain things that couldn't happen. And here was one of them. We said this position, this base position cannot be a 1. And you might be like, well, why not? It can be a 2, a 3, a 4, a 7, a 10. It doesn't matter. Well, yeah, it does. Imagine you do the little evaluate and lap it around. 1 to the power x is equal to 9. Now, what's the power? Silence is golden because there's nothing you can do. 1 to any power is still 1. It does not work. That's why it says no solution in the PDF notes. And another one that we will see, this position can't be a negative 8. And you should still be kind of saying, well, why? But now with a little bit of skepticism, not a confident, well, why not? Because if you do the loop around, 2 to the power x is equal to negative 8, what power would this be? Well, 2 cubed is 8. Some people think put a negative there. Well, that's not right either. 2 to the negative 3 means flip 1 over 8. You can't get it to happen. So again, this is no solution. That can't be a negative. And it's just some of those clarifications of what is not allowed to happen. And don't worry, you will not be tricked by me into what are these values. Now, for number 2, the simplify. This is your second thing that we can do. One thing we can do is we can evaluate what is a value. Now we can simplify using the rules of logarithms that we saw on section 8.3 day 1. The things like when you see an addition, if your base is the same, you can move this together to be a multiply. When you have a number out front, you can bring it up as a power, or vice versa. You can bring it up and down. That's a very useful idea. And here is how this guy would unfold. What I'm going to do is just a couple of double duties, even though I know I'm supposed to do brackets first. I'm going to take this power of 4 and I'm going to bring it up. You can bring it up and down, whatever suits your needs. You're not supposed to know exactly what to do without a little bit of experience. I'm going to leave the half alone, but I know I'll eventually bring it up. And on the inside, I'm going to do two things at the same time. This 5 comes up as a power. You don't have to be erasing. And then an addition means we can put it together as a multiply. We can put this together as an x multiplied by an x to the power 5. Now, what would this simplify down a little bit further to? Log 3x to the power 4 minus, and now what we have is we have a log of 3, and when we're multiplying, we add the powers, and if I bring this half up, we see that this is a total power of 3, and then here's our grand finale. A subtraction means that we can take the original thing, x to the power 4, and this was an x to the power 3. We can divide them, and our final answer, sorry I'm squeezing it in, this is sloppy, is log 3 with just an x. So what we were doing is we were taking this expression, we were not evaluating it. We were not saying what is it equal to, because you can't type this into your calculator. We were saying what does it simplify down to, and this is our simplified answer. Now, our final example, we get some rewarding things and we get to apply the rules of the logarithms. The final example looks like this. It goes log with a base of 2 and then x squared minus 9, and then it goes subtract a log, and then again, it has to be the same base or else the rules don't apply. And we have x squared minus x minus 6. And I know what you're thinking. You're thinking, I wonder if I have to eventually factor. And you do. How exciting. So what would this guy simplify down to? Here's what I would do in my first step. In my very first step, I would just say, okay, a subtraction can be brought together as a division. These are the rules of logarithms that have been proven to be true. They were proven with just simple numbers first, and we trust in the rule and we just apply it even though there's variables and we're not getting a final solution like a 6 or something like that. So now is the stage where you would trust your instincts and you would factor this because we don't live underneath rocks. And the factoring is usually pretty simple. Rarely is it anything that's going to challenge you guys. And we would see what crosses out. That's one of my favorite things in the world to do. And this is what we would be left with. We'd be left with an x plus a 3 and an x plus a 2. There isn't supposed to be such a gap here. And that's what this original expression would simplify down to, doing some basic factoring and then applying the rules of logarithms, that a subtraction can be brought together into a division and it means the exact same thing. If we had numerical values, not variables, it'd be the exact same ultimate answer. Now here's where I just want to remind you guys of this, and I'll probably do this more times than just now. When you're working with logarithms, we're just trying to learn it as a skill, and we need all of these skills in place so you can apply them at a calculus level or even in a chemistry class. But then again, it comes in, well, what is a logarithm? You go through all of this and you're like, okay, I can do logarithms till the cows come home, but I don't really remember what a logarithm is. This is not in the notes, but I would have done this on the board anyway. I want you guys to remember the graph of a logarithm. You just memorize this graph. It's one of your memorized versions. And again, what is this? Where did that graph come from? A logarithm is an inverse to an exponential equation. It is that flick over the lines. It is the reverse. If this point right here is 0, 1, well then its inverse, remember when we did the switch of the hands, is right here, and this is 1, 0. And so a logarithm is the inverse of an exponential. But then what they found is there's a whole bunch of things you can do with logarithms, not just graphs and moving them wall window. And they're very, very useful in solving problems in calculus. That's why you're learning them just as a skill, and then you'll be able to apply them in a further class.